Alright, this is section 2.2 conditional statements. Let's start with the solve it. The company that puts the bumper sticker at the left below accidentally reworded the original statement and printed the sticker 3 different ways. Suppose the original bumper sticker is true. Are the other bumper stickers true or false? Explain. So, you can't see it in the bumper sticker. It reads, if you can read this, then you are too close. So the other 3 bumper stickers that they printed were A, if you are too close, then you can read this. B, if you cannot read this, then you are not too close. C, if you are not too close, then you cannot read this. So if you think about it, and you really think about it, which statements rewritten from the original bumper sticker are really true if you just change the wording around? So these if-then statements are called conditional statements, which we will go over more in depth tomorrow. So the hypothesis is the beginning part. If you can read this, if you can read this is a hypothesis. The conclusion is, then you are too close. So let's look at problem 1. Okay, that would be good. Okay. Kind of. Okay. Alright. So, in problem 1, they're asking you to label the hypothesis and the conclusion. We're going to label the hypothesis P and the conclusion Q. So, if an animal is a robin, then the animal is a bird. Oh, you can't see that. Maybe now? Okay. So, if an animal is a robin, that's the beginning part. So this whole thing right here, that's your hypothesis. Then the animal is a bird. The animal is a bird is your conclusion. Hypothesis beginning, conclusion at the end. So why don't you try to got it? Alright, problem 2. They want you to write this statement, vertical angle share vertex, as a conditional. Now the conditional has an if-then statement. So this is how this is the process that the book wants you to use, and it's a pretty good one. Alright, so they first want you to identify the hypothesis and then the conditional. So hypothesis is vertical angles, and the conclusion is share a vertex. Because what about vertical angles? The conclusion, they share a vertex. So now that we did step 1, we identified the hypothesis and the conclusion, we can do step 2. Now we can write if 2 angles are vertical, then they share a vertex. Okay. So if you could see this, alright. So that means that 2 angles are vertical, that's your hypothesis, then they share a vertex. That is your conclusion. Alright, so why don't you try to got it? Okay, now we're moving on into problem 3. Problem 3 now is asking, is the following conditional statement true or false? If it is false, find a counterexample. So let's look at problem B. If a number is divisible by 3, then it is odd. Well, let's look at the numbers that are divisible by 3. 3, 6, 9, 12, 15, 18, and so on. So, 3 is odd, 6 is even, 9 is odd, 12 is even, and so on. So we could circle 18 too. too. Okay. So, therefore, we found our counterexample. So, therefore, this statement is false. You even see it? Probably not. Okay. Then it is false. And the counterexample would be 6 is divisible by 3. And it is even. Rather say it's even, you should say it's not odd. Because we're proving this part wrong. Proving this part false. Alright, so why don't you try to got it for problem 3. Okay, so before we move on to problem 4, this is what I'm going to go over tomorrow, but I just want to tell you that these words really quickly. Negation means that it's denoted by a tilde. This is negation. It's a not statement. So it would be like not P, then not Q. Alright, so these are some conditions. Converse means you're switching your conclusion with your hypothesis. Inverse means you're negating your hypothesis and conclusion. So not P, therefore not Q. Contrapositive, that means you're reversing your hypothesis and conclusion, and then you're also negating them. So not P, not Q, then not P. Alright, so these are the truth values. I'll go over more in depth tomorrow. The conditional is always true. If something, then that. If you use the converse or the inverse, they are false. If you use the contrapositive, that is true. So let's try to look at this for problem 4. Okay. If the figure is a square, then it's a quadrilateral. So they want us to write the converse, the inverse, and the contrapositive. So let's start with let's first identify our hypothesis and our conclusion. So hypothesis in the beginning, the figure is a square. That's our P. Then is a quadrilateral. This is our conclusion. This is our Q. So converse is Q then P. This stands for then, or implies, try to say. Alright, so if we look here, converse is Q then P. So converse is if the figure is a quadrilateral, then the figure is a square. So you can see here that if the figure is a quadrilateral, then the figure is a square. That's not always true, because the quadrilateral could be a trapezoid. Oh, you can't even see. And that's definitely not a square. So this converse is sometimes true, but not necessarily, not all the time, because we have a contrapostive. I meant a trapezoid. Alright, so now the inverse. The inverse is not P, then not Q. So therefore, if the figure is not a square, then the figure is not a quadrilateral. If the figure is not a square, then the figure is not a quadrilateral. Well, that's not true again, because this is not a square, but it is a quadrilateral. So that's 4 sides. Alright, now let's do the contrapositive. The contrapositive is not Q, then not P. So, if the figure is not a quadrilateral, then it is not a square. And that is definitely true. Alright, so with these definitions, why don't you try they got it? And then if you have any questions, we'll go over in class tomorrow.